Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will use the quotient rule. You use that when you want to differentiate when it's one function divided by another. So that's what this says. When we have a function divided by another and we want to take its derivative, we use this formula here. Derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by what's on the bottom squared. So once again, u is a function of x, v is a function of x. So I went through a proof in a previous video. Let's now get to some examples. So let's look at this function here, which is actually one function divided by another function. We actually did ones like this last year. You needed to use a bit of ingenuity, a bit of algebra. What we'd do is we'd write it as x plus 4 on top, and then we'd subtract 4 over here. Now, you can do it that way, but this way is probably going to be easier. So u is the thing on top, which in this case is x. So that means u dash, derivative of x is just 1. And then v is the thing on the bottom, and then v dash is just the derivative of x plus 4, which is also 1. So just note, u here means du dx, and this means dv dx. Okay, so now we've got all we need to put it into the formula. So the derivative of this fraction here, so it is the derivative of the top times by the bottom, so I'm just going to put it in brackets, minus the top times the derivative of the bottom, and then what goes as our new denominator, the bottom squared. So I can actually fix up the top, x plus 4 minus x, well that just leaves you with 4. So it turns out that we get 4 over x plus 4 squared. So that is our answer. So they're not all like this, where they all, simplify to something that looks quite neat. This was just an easy introduction. Once again, I wrote out the u's and v's, which you might want to do at the start, but once you get the hang of it, this might not be worth your time doing. All right, let's look at some other examples. So we will differentiate each of these using the quotient rule. So what we use for the quotient rule, we take the derivative of the top. So the derivative of e to the x squared. Hopefully you know by now that I just differentiate what's in the power and then leave the e and the power alone. So 2x e to the x squared, that is the derivative of just the top. So then I'm going to multiply that by the bottom. So this is quite a complicated one. And then I subtract the top multiplied by the derivative of the bottom. So the derivative of the bottom here is just 2x. And then what goes on the bottom? Bottom is now squared. So that's actually the derivative. I'm just going to make this a bit easier to work with. See, I can factorize the top because they both have a 2x. And they both have an e to the x squared. So taking that out as a factor, 2x e to the power of x squared. So what do I need to multiply by this to get the first term? Well, it's just what's in brackets, the x squared plus 1. And then what do I need to multiply by this to get this? Well, you can see it's already 2x e to the minus x squared. So I just need to multiply by minus 1. And of course, x squared plus 1 minus 1, I can just rub that out. It'll just be x squared. And then I'm going to keep the thing on the bottom, which is x squared plus 1 all squared. Okay, and of course, 2x times x squared, that just equals 2x cubed. So I'll just put a cubed here and rub out the x squared. So this one was complicated, but it's simplified quite nicely. Sometimes that will happen. A lot of the time it won't. Just see if the top can be simplified, because if you're given a question like this, you will be asked to write your answer as simply as possible. All right, let's do the second one. Fx equals tan x. So you're probably thinking to yourself, what's this silly old man talking about? Tan x isn't a quotient. I don't have one function divided by another one. Well, see, I don't know how to differentiate tan x, but remember tan x is just sine x over cos x. So I know how to differentiate sine x, I know how to differentiate cos x, so I can use the quotient rule. So the derivative of this, it will be the derivative of the top, so derivative of sine x is cos x, derivative of the top times the bottom, minus the top times the derivative of the bottom. Now remember, the derivative of the bottom, the derivative of cos x is minus sine x. So it'll be minus sine x times minus sine x. So that's on top, and what goes on the bottom is the bottom squared. So just making the top easier to work with. So remember, cos x times cos x is cos of x squared. We usually write it like this, cos squared x. This and this mean exactly the same thing. We just write it like this, remember, to avoid any ambiguity. Are we taking the cos of x and just squaring the x, or are we taking the cos of x and then multiplying by itself? So cos squared x, this becomes a positive because it's minus times a minus. So we get cos squared x plus sine squared x over cos squared x. Now, remember, cos squared x plus sine squared x is always 1. That's due to Pythagoras' theorem. So I just get 1 over cos squared x. That is the derivative of tan x. 1 over cos squared x, made possible due to the quotient rule. So I'm not just some silly old man. We can actually use the quotient rule on tan x. The quotient rule, very, very useful. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.